Hi, we will show a quick demo explaining how to use a topological folding algorithm to reconstruct geometric modeling operations, everything implemented within the Jerboa platform. So let's have a look at Jerboa. As you can see on the left, there is a series of already implemented operations. We used one to create a square, which we are now extruding to obtain a cube. An important aspect about Jerboa is that you can see either the object or the underlying Gmap. There is even a view that combines both this geometric and topological information, which is properly modified when applying an operation. At the moment, we have no operation, neither in the viewer nor in the editor. The first step of our inference mechanism is to specify the before instance, in this case a cube, and the after instance, in this case a subdivided cube. We now are building a partial mapping from the left instance to the right instance. We'll use Jerboa to only specify the mapping on a few darts and associate the subsequent vertices. We specify the target orbit. Here it is 0, 1, 2 for an operation on a surface, and run a topological folding algorithm. As we can see, it built a graph transformation rule which depicts the topological part of our modeling operation. To obtain the complete operation, we have to specify the missing geometric computation. For the quad subdivision, we write that the new edge points are placed at the middle of the initial edges, while the new face points are placed at the barycenter of the initial faces. The Catmull-Clark subdivision is topologically equivalent to the quad subdivision. So, from this same inferred operation, if we specify a different geometry, we'll obtain the Catmull-Clark subdivision. We are copy-pasting the different computation to gain a bit of time, but we can see that there are only a few lines of code each. Now we are exporting these two operations back in the viewer. If we apply the quad subdivision on the initial cube, we will see that each square is subdivided into 4 subsequent squares. Conversely, the Catmull-Clark subdivision would smooth the surface, turning the initial cube into a sphere. Similarly, we can infer the two Sabin subdivision using the standard T-shape. We will load the mapping to speed a bit the video, specify the target orbit to that of the surface, which is 0, 1, 2, and run our algorithm. As we can see, our algorithm reconstructed the rule. We are duplicating it to modify it, giving it a proper name, but as you can see, we already have the graph transformation rule depicting the topological modification. We just need to add the geometry computation, which consists of 5 lines of code. Our operation is now ready. We can export it and go back to the viewer, where we will apply it on the initial T-shape. We obtain the first iteration and afterwards the subsequent ones. Thanks for watching.